This next video is going to go over how to graph a quadratic with a calculator. So make sure you have a calculator handy when we're going over this. The first one we're going to graph is our parent function. So yes, this is a parent function in which we are graphing y equals x squared. So the first thing you want to do is in your calculator, hit the y equals button, which is right here, top left. And then once you're on y equals, you want to type in x squared. So the x button is right here next to alpha. The squared button is actually this x squared button right here. So if you type x and then x squared, your screen should look something like this, x squared. Once you have done that, we are going to bring up a table. So you are going to now hit second, which is the yellow button, and then graph. Once you hit second graph, a table should pop up. Now, my table looks a little different here, but you should still be able to fill in the missing values. Okay, so when you plug in 0, the calculator should give you a y value of 0. When you plug in 1, the calculator should give you a value of 1. 2 gives you 4, 3 gives you 9. Because we are plugging all of this in to x squared. So 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. Negative 1 squared is 1. Negative 2 squared is 4. And negative 3 squared is 1. Now we're going to graph this on the calculator to see what it looks like. So we have 0, 0. We have 1, 1. We have 2, 4. We have 3, 9. Negative 1, 1, 2, 4, negative 3, 9. When you are graphing these, you want to plot as many points as possible. So as many as you can fit on the graph. Now, if you look at our parent function, it is symmetric around the y-axis, around this line right here. And your vertex is actually the origin. So let's look at what that means on our table. We just said that our vertex is 0, 0. Well, if you notice, the y values match as you go out from their vertex. That is because parabolas are symmetric. So if you look at your graph, 1 and 1 are symmetric around the axis of symmetry. 4 and 4 are also symmetric. If we were to fold this in half, those points would touch. So now we're just going to label these like we did in the previous video. So the vertex, we said, is the origin, which is 0, 0. For this one, it is a minimum. The minimum value is 0. I already labeled our axis of symmetry. It is actually the y-axis, which means x equals 0. Remember, this should always match the x on your vertex. We only have one x-intercept, and that's actually the same as our vertex. So we label that 0, 0. We also only have one y-intercept, also 0, 0. The domain goes left and right forever. So the domain is all real numbers. And for the range, we're going up forever, but we start at 0. So we label that y is greater than or equal to 0. Now, if you're having a hard time figuring out where to look on the table, you can always hit graph on your calculator first and see where it's centered around. When you graph this one, it should be centered around 0, so that's a good starting place. Now, for the next one, we're going to graph x squared minus 2x minus 3. So your very first step is to go into your calculator and hit y equals. Once you've hit y equals, clear whatever is there, and you're going to type in x squared minus 2x minus 3. Then you're going to hit second graph to pull up your table. Now, this one is not the parent function, so we can go ahead and say no for the very first question. Once you have the table from your calculator, we can fill this in here. Okay, if I plug in 0, I'm going to get out -3. If I plug in 1, I'm going to get -4. If I plug in 2, I'm going to get -3. If I plug in 3, I'm going to get 0. And then if I plug in -1, I'm also going to get 0. Now I'm going to actually keep going because we can actually fit more points on this graph. If I plug in 4, I'm going to get 5. And if I plug in 6, I'm going to go off the graph. So we can actually just stop at 5. Same thing with the other way. If I plug in -2, I am going to get 5. So let's plot these points. We have -2, 5. We have -1, 0. We have 0, -3. 1, -4. 2, -3. 3, 0. And 4, 5. Oh. All right, so my vertex here is this point right here. You can find it on the table or the graph because if you notice, everything is symmetric around 1, -4. So my vertex is 1, -4. This is a minimum with a value at -4. The axis of symmetry is the vertical line that goes through the vertex. So my vertical line here is x equals 1. Remember, it should always match the x on your vertex, but please make sure you always write it as an equation because that is an equation of a line. We have two x-intercepts here. We have one here and one here. So we're going to write that as 1, 0 and 3, 0. And we have a y-intercept right here at -3. So we label that 0, -3. It goes left and right forever, so my domain is all real numbers. And then it starts at -4 for the range and goes up forever. So my range is y is greater than or equal to -4. We've labeled all the parts. All right, the last one we're going to do is y equals 2x squared minus 12x plus 16. So the first thing you're going to do is in your calculator, hit y equals, and then I want you to hit, plug in, 2x squared minus 12x plus 16, and then hit second graph to pull up your table. Take a second to look through the table and try to find where our axis of symmetry is, where we are centered around. You should see that we are symmetric around where x is 3. So we're going to kind of center our table around 3. If I plug in 0, we're going to get out 16. If we plug in 1, we're going to get out 6. If we plug in 2, we're going to get 0. If we plug in 3, we should get -2. 4 should give 0. And 5 should give 6. So when we plot these points, we have 3, -2. We have 4, 0. We have 2, 0. 5, 6. 1, 6. And 0, 16 is not going to fit, so we're only going to plot those points. Okay, so this is not the parent function. The vertex is this point right here, which is 3, -2. This is a minimum because it's going up. The minimum value is -2. Our axis of symmetry is the line that cuts it right in half. So my axis of symmetry is at x equals 3. I have two x-intercepts. I cross at 2 and at 4. So we're going to label that as 2, 0 and 4, 0. And then here's the tricky part on this one. On our graph, it looks like there's not a y-intercept because we couldn't fit it. But if you look at the table, if you look at your calculator table, I am crossing y at 16. And the reason we know that is because the y-intercept is always where x is 0. When x is 0, y is 16. So even if you can't see the y-intercept, you still have to label it based off of the table. Now, my domain goes left and right forever, so all real numbers. And my range starts at -2 and goes up forever. So y is greater than or equal to -2. Now, the sub is going to give you a worksheet, and I want to explain it before you get to work. On this worksheet, it should look like this. There was a copying problem, so it looks like a big packet, but really all you have to do is 1 through 8. So don't worry about the last 2 pages. All you are doing is 1 through 8. Now, I know you don't have a calculator at home, so what I want you to do is work for the rest of the period and just turn in what you can get done. I will take a completion effort grade based off of that. Just prove to me that you worked for the period, and then we will go over this again on Friday, I promise.